Okay, good evening. Welcome back to pre-calculus. So we are graphing some sine functions here. Okay. So what we're going to do here is say, what if we had a problem that looked like graph y is equal to sine of 5x plus pi over 4. Okay. Now, before I get started with this, what if I just add as graph the parent function, graph y is equal to sine x? Okay, they'll probably put something else in here where it's like label at least 5 points. Okay, so we can go off of that. So if I have to graph my y is equal to sine x, how would I do that? Well, I would know what to do because we can graph y equals sine x. I'm going to go from 0 to 2 pi. Half of 2 pi is 1 pi. Half of pi is pi over 2. And if I take and find the average of pi and 2 pi, right, that's pi plus 2 pi all over 2, we get 3 pi over 2. So we have 3 pi over 2 here. So I would dot in what's going on. Okay, that's 1. Back down to 0. Okay, got the negative 1 down here. And I would go ahead and dot in my graph. Okay, but that's not really the points we want, right? That doesn't take into account for this phase shift. It doesn't take into account for this period change. There's nothing going on here. Okay, so what we're going to do is there are a couple of key points, 1, 2, 3, 4, 5 of them, in fact, that I have. So if I could make this argument equal to the points that I have here, I would know what the x's were. It would be a lot easier to graph that. So what we're going to do is we're going to say, take this argument and set it equal to the 5 points we have here. So I'm going to take my 5x plus pi over 4. Okay. So let's see here we have. So we're going to have our 5x plus pi over 4 equal to 0. And we're going to solve for x. So we're going to say this is 5x equals negative pi over 4. Right, subtracting pi over 4 from both sides. And then we're going to say x equals negative pi over 20. Right, divide both sides by 5. Second point, we have 5x plus pi over 4 equals, what's our second point? Equals pi over 2. And we're going to solve for x for this one. So we're going to say, okay, well, this is 5x equals pi over 2 minus pi over 4. We could do that, right? We have to get common denominators, but that's not too bad for this case. So we have 5x is equal to 2 pi over 4 minus 1 pi over 4. So we have 5x equals 2 minus 1 would be 1. This will be pi over 4. And then finally dividing both sides by 5, we get x equals pi over 20. Okay, so we started with pi over 2. The x value to give us the argument of pi over 2 is going to be pi over 20. We plug in x equals pi over 20 into here and run this through, we're going to get pi over 2. Okay, what about the third point? We have 5x plus pi over 4 equals pi. Okay, and I'm going to be a little bit clever here. At least I think I am. 5x plus pi over 4 is equal to, can I say 4 pi over 4? That keeps me from having to deal with the common denominator just yet. So we have 5x is equal to, subtract pi over 4 from both sides, we get 4 minus 1 pi over 4. That's going to be 3 pi over 4. Or x equals 3 pi over 20. How about the next one? That's 5x plus pi over 4 is equal to 3 pi over 4. Or 3 pi over 2, rather. 3 pi over 2. And then we'll solve for x for this. So that'll be 5x is equal to 3 pi over 2 minus pi over 4. Again, we got to get common denominators. 2 by 2, that's okay. So this is going to be 6 pi over 4 minus 1 pi over 4. So we have 5x equals, right? 6 minus 1 is going to be 5 pi over 4 here. And we divide by 5, and we'll get 5 pi over 20. Okay, and the reason why I want to do it that way is because we have negative pi over 20, positive 1, so negative 1, positive 1, 3, 5. What do you think the next one's going to be? Right, so let's find out. It's 5x plus pi over 4 is equal to 2 pi. Right, that's the last point. So we have 5x is equal to, instead of 2 pi, I'm going to say this is 8 pi over 4. That's really a fancy way to say 2 pi. Minus pi over 4. We have 5x equals 8 minus 1, 7 pi over 4. And then x will be 7 pi over 20. Right? Now we can go back and reduce this. Okay, so if I were to go ahead and graph this thing, okay, we're going to have a negative pi over 20 here, positive pi over 20. Okay, what was my next point? Was 3 pi over 20. My next point was 5 pi over 20, or pi over 4. And then my last point was 7 pi over 20. And again, we're only graphing this for like one cycle. That's okay. So we start off here, right? Pi over 20. We're going to be up here at positive 1. Back down here. So up here. Okay, 5 pi over 20. That's going to be down here at negative 1. Because if I put in 5 pi over 20, what are we going to end up with? We're going to end up with 3 pi over 2. So that's going to be down here. And to finish this guy off, we're going to be back at 0. Okay, so here would be the 5 points that I would have. Okay, and that's another way to graph a sine or cosine of it has a linear argument to it. Okay, so there's a number of ways to go, but I like this method. But there's, if you were my student, you could pick a myriad of other methods. Okay, so thank you for tuning in, and happy graphing. Thank you.